Tesla is a popular name in the present-day automobile industry. It currently holds the title of world's largest EV maker, with more than a 20% share in the fully electric vehicle segment. In the year 2021, Tesla sold more than 100,000 units of each Model 3 and Model Y. Next to them was the Ford Mustang Mach-E, with around 27,000 units sold. Clearly, other EV makers are not all close to Tesla when you compare the sales. With their latest Model S Plaid, they have done something that could change the entire industry in the upcoming years. Welcome to Science Today, where we present to you the latest news and research within science and technology. In today's video, we'll look at Tesla's Model S Plaid and how it is chiseled for performance like no other EVs ever before. When you try designing an engine, you'll know that it is hard to maximize the traction and put the power down immediately to accelerate the vehicle, whereas to achieve a top speed, all you would need is a bigger engine. This is why acceleration is given priority over speed when we rate the performance of an engine. Speaking of acceleration, Tesla's Model S Plaid can go from 0 to 60 miles per hour in 1.99 seconds. This is second only to the Koenigsegg Gemera, which can do the same in 1.9 seconds. It also has a drag coefficient of 0.208, which makes it one of the most aerodynamic production cars on the market. A major drawback we had with electric vehicles was that their power dropped off significantly with an increase in speed. This would mean that your vehicle would become less capable of pulling itself as you try to hit higher speeds. But S Plaid has a peak power of 1,020 horsepower, and Tesla claims that it maintains 1,000 plus horsepower all the way to its top speed of 200 miles per hour. Furthermore, it holds the record of covering a quarter mile in 9.081 seconds. You may also be surprised to find that the battery pack they come with looks more like ordinary lithium-ion batteries that are arranged in modules, but are better in many ways than the ones we have for domestic usage. Their battery pack comes with 18 650 batteries that are more energy dense than the previous Model S and Model Y, with the glycol coolant being used to cool the batteries. Model S Plaid's powertrain has some interesting engineering gone inside it. What they have are 3 asynchronous AC motors, 1 in the front axle and 2 in the rear. This makes it the first Tesla to come with 3 motors. The stator, which is the fixed part that drives the rotor by generating magnetic fields, is the same as those in Model Y and Model 3. It's a 3-phase stator surrounded by cooling rings to help them take away the heat generated due to the resistance, so there's nothing special about that. The differential is usually a set of gears that prevents the car from skidding at turns by enabling different wheels to move at different speeds. Model S Plaid, having motors in both the front and back, with both the rear wheels attached to each motor, it can operate the wheels independently without the need for a rear differential. So we can say that what we have here is not a mechanical differential, but rather an electronic one that knows when to move which wheels. When it comes to the rotor, the laminate stack that holds the magnets inside doesn't touch its outer edges. Tesla claims in their patent that they are able to get about a 25% increase in both peak power and torque by arranging the laminate and magnets this way. They were able to produce 20,000 RPM with this minute change, from which we can learn that even a small gap can do magic at times. It is common to place the magnets in a manner such that they produce skewed field lines. This helps us avoid noise and give a smooth ride for the driver. A recent video by Monroe Live, where they ripped apart a Tesla, was really helpful for us to know a lot of unpopular facts about it. They showed that the field lines from the rotor are straight and parallel to one another. This is likely to produce a pulse that would give us a jerky experience during the ride. But there seem to be no such issues with the S Plaid. The way they pulled this off turned out to be a surprise to even engineers who are familiar with the technology. Not to mention that the magnets they have used are roughly 35% stronger than the ones in Model Y. The rotor is the part that rotates to move the wheels. They are always covered by an outer layer known as a sleeve to prevent the magnets or coils from flying away as they do thousands of revolutions in a minute. These sleeves are usually made of some metal, since their coefficient of thermal expansion is more or less similar to the metal placed inside them. Because of this, at a higher temperature, the sleeve would expand with the rotor as a whole, thus keeping the rotor intact without any gaps in between. But metals are good conductors as well. As the rotor speed increases, stronger and stronger eddy currents are produced in the sleeve, which does no good to the performance. Moreover, that's a way to mess up efficiency. So it turns out that they have used a carbon fiber sleeve on their rotor. Unlike metals, carbon fiber has a very low thermal expansion coefficient, which means it hardly reacts to changes in temperature when compared to metals, and they are not very flexible. This would put the integrity of the rotor at risk. Earlier, Musk had mentioned in one of his tweets that they had wound the copper in the rotor with a carbon fiber sleeve and put it at compression to avoid it from slipping due to differences in expansion at low temperatures. This shows they had to wind the rotor at an extremely high tension for integrity. They needed a machine that could do this, which was not available in the first place, so they designed one on their own at the Tesla automation factory located in Germany. But they have an advantage. Carbon fibers are poor conductors of electricity, which makes them incapable of producing any eddy currents, unlike the metal sleeves. Hence, using it as a sleeve is not a bad idea, as it would increase efficiency by producing stronger magnetic fields around the rotor. Also, it enables the rotor to unlock greater revolutions per minute, since the tight carbon sleeve could stop it from expanding due to rotation. This is not something entirely new. We have used carbon fiber sleeves in other high-speed machinery before, but this is probably the first time a production vehicle has used a carbon fiber sleeve in its motor. Batteries store energy in the form of DC, but the motors that are given inside the Plaid use AC. Hence, we convert the DC from the battery to AC with the help of an inverter. The inverter is like the brain for speed control, as it regulates the power needed for the motor. Then it's comprehensible that any malfunction in the electronics present in it would end up damaging the motor. To prevent this, Tesla has ensured multiple fail-safe fuses that open the circuit without damaging other components in the inverter. Also, when you take the inverter from Plaid's motor and try to fit it into the motor of any other Tesla model, it would fit perfectly. However, that doesn't mean that they are all the same, since there are a lot of electronic components that vary from model to model. Their upcoming Cybertruck and next generation Roadster will feature a similar tri-motor technology, so it would have been crucial for them to make sure that their first impression does not turn out to be a disappointment. And from the looks of it, they have done a good job of making it work. Elon has said that they would provide a SpaceX pack for their upcoming Roadster that lets you have cold thrusters on your car. Cold thrusters are used in smaller space missions to steer spacecraft. They produce just enough thrust by releasing pressurized gas and have a much simpler mechanism than an electric motor. By the estimates given by Elon, it could make the Roadster accelerate monstrously from 0 to 60 miles per hour in a mere 1.1 second, which would make it the fastest production car ever in terms of acceleration. Tesla is a forerunner that keeps pushing the boundaries of technology. Producing everything in-house has let them tweak their cars to the extent they want. Hopefully, we can see cheaper and better electric vehicles coming up in the future, as long as companies like these bring the distant reality closer day by day. What could be the next big upgrade they come up with? Let us know what you think in the comments section. Also, don't forget to like and subscribe to us. Thank you for watching.